So this is going to be our discussion on therapeutic heat. We're going to be focusing on, primarily in this discussion, is the application of superficial heating modalities. We're going to leave some of the deeper heating modalities for discussion later on. So we'll be talking about them, plus discussing just some of the basic science behind what goes on with heat exchange as we apply these different modalities to the body. So just to look at some of the objectives, so we're going to go through heat energy, and some of what we're going to be talking about as well, even though it doesn't all completely relate to some of the modalities we're going to be discussing here, we're going to be talking about electromagnetic energy and how that kind of impacts different heating modalities as it applies to the body. So there's going to be some terminology here as it relates to how our body absorbs heat from these different modalities. We're going to talk about the general physiology of heat, some of which we did talk a little bit about in lab, just kind of expand on those concepts a little bit and then get into the specific clinical indications as it relates to the application types, and then the contraindications, the indications, and the different precautions as they relate to the modalities. So just to understand a little bit of the science behind heat, because this kind of makes it relevant as it relates to, again, as we're applying some of these different things to the body, what is going on. So to understand, heat at the very basic level is the movement of atoms and molecules. So as atoms and molecules kind of move, they create energy, and essentially the faster they move, the hotter something gets, or basically the more heat that gets generated. And at the point where you're above what they consider absolute zero, you technically have heat. And that's where we get into the whole heat and cold discussion. Cold is technically the absence of heat. So when we're talking the kind of the pure science aspect of it, there, and your book describes this as well, there's really no such thing as cold. Cold just means the absence of heat. And that's when we look at these different modalities, when we look at heat and cold modalities, regardless what it is you're applying, whether it's something that's heat or something that's cold, you always have a transfer of heat. So when you put a moist hot pack on someone's arm, for instance, the moist hot pack is giving off heat to the arm. If you put an ice bag on someone's arm, the ice bag isn't giving off cold. What the ice bag is technically doing is absorbing heat from the body part. So that's kind of a relevant thing when you're kind of looking at how deep some of these modalities are going to go, and also your time of application. So this is just some little background, and again, some of this we discussed already in lab. So when we're talking the concept of temperature, so we all kind of know at a very basic level what temperature is, but when we look at kind of how it's derived, it's the measure of an object's ability to spontaneously give up energy. And again, what this essentially is going to relate to how much molecular motion is actually happening. Again, the faster the molecules and atoms move, the more heat you're going to generate, and then the higher the temperature is going to be of an object. So, and the object's ability to give up that energy. So as the atoms and molecules move faster, the higher the temperature gets. So when we look at heat transfer and the ways that different objects transfer heat to each other, and these were things that have been probably discussed in your intro class as it kind of relates more to environmental heat transfer. We have 4 different types. We have conduction. So that's when there's a temperature gradient between 2 objects. So essentially what happens with conduction is that when an object is in direct contact with something, if there is a temperature gradient or a difference in temperature, one object will give off heat to the other. So, and heat moves from an area of high to low. So again, for instance, a very basic example of this would be, again, putting that moist hot pack on the skin. You put the moist hot pack on the skin, they're in direct contact with each other, you get the transfer of heat from the hot pack to the body part. Convection is either the movement, what they call a movement of a circulating medium. And the circulating medium can either be fluid or it could be air. So when there is the movement of that circulating medium, again, the heat transfer will go from an area of high to low. So you have a couple examples of this. You have the whirlpool, could be an example of something that transfers heat via convection. And you also have another example of this that we talk about that you probably haven't seen at your clinicals, is something called the flutotherapy unit, where basically a machine blows warm air and what are essentially basically ground up corn cobs around the body part, and that will transfer heat via that mechanism. Another form is through what's called radiation, and that's the transfer of energy and heat through waves, rays, and particles. So not so much a direct application of modalities, but still a heat transfer mechanism. So this is where, when you're outside on a very hot sunny day, the sun will give off radiation, and that's a way to get heat transfer that way. If you've ever played basketball or did any type of activity on a hot blacktop, you notice how much hotter it is because of, again, the heat that kind of comes off of the blacktop when you're outside. It's another mechanism of heat transfer. And then the last one you have is conversion, and that's that's when you have one energy gets converted to another. And the example that we have, and again, they're not so much the modalities that we're looking at here. An example of this would be ultrasound, which would be a deep heat, but essentially what's happening is with an ultrasound unit, the ultrasound takes electricity, converts it to another form of energy, which basically ends up producing heat. So the ultrasound would be an example of that. So just some different mechanisms of heat transfer, along with some examples as to how that takes place. So again, when we look at some of the benefits of therapeutic heat, again, you have to remember the forms that we're looking at here are only going to have a penetration up to about 1 centimeter. So, while you can get with some more superficial joints some of these effects in a much greater manner, for the most part, everything's going to be very superficial. So some of the things that look to go on with therapeutic heat, obviously some nutrient delivery and waste product elimination. Again, part of that will be due to the increase in circulation that occurs. Really what you're looking to get with a lot of this is the promotion of relaxation and decreased stiffness, and a lot of the general soreness that people have. So again, when you're thinking about when you're applying heat versus cold, you have to kind of look at what type of pain the individual is dealing with and what it is you're trying to promote. And it's assumed to increase the rate of healing. Again, some of this will probably be, majority of this will be impacted by how superficial the area is. So the increase in circulation that happens, obviously will be more effective the more superficial the area is. And I've talked about this before. Active exercise, in as far as doing a lot of the things that even we're talking about here, is going to be much better. You're going to get a much greater increase in tissue temperature. You're going to get a much greater increase in circulation to an area. Even going obviously a lot deeper than what a lot of the superficial heating modalities can produce. So it's something to think about in your treatments when you can get an individual to do more active ways of promoting these effects that you would want to encourage them and want to promote that type of activity as opposed to the passive application of superficial heat.